This next video is a continuation of what we just did. So what we just did is we found ordered pairs that satisfy an equation so that we could give a graphical representation of a two-variable equation. Now, to find random points can sometimes be difficult. So what we do is we focus on 2 points that are the easiest to find when you are looking for points to graph an equation, and those are the x and the y intercepts. So just a reminder, to graph a line, you need at least 2 points, ideally 3 or 4. And the easiest 2 points to find are the x and the y intercepts. Now the x-intercept is the point, if any, because sometimes there isn't, where a line intersects the x-axis. So the x-intercept is a point here or anywhere along this x-axis. Now to be on the x-axis, the important thing is that the y value is 0. So an x-intercept will have an x-coordinate and a y value of 0. Whereas a y-intercept is the point, if any, where the line intersects the y-axis, so somewhere on this vertical axis. And to be a point on the y-axis, there's no left-right direction, so the x value is 0. And your ordered pair would be 0 something. So what we're going to do is we're going to practice graphing lines. So this is just, again, a continuation. We already learned how to graph a line. We can use a table of values. Plug in x, solve for y. Plug in y, solve for x. This is just 2 very particular points that we're going to find. So to find the x-intercept, what do you have to remember? What do you let equal to 0 to find an x-intercept? Well, think about the fact that you want an x value. So we're going to let y be 0. So in your equation, 2x minus y equals 4. We're going to let y be 0. So 2x minus 0 equals 4. Leaves you with 2x equals 4. So the y value disappears altogether. In fact, when I'm finding x-intercepts, I don't even write much. I like cross out. Here, I should do that in a different color. I cross out the y value right away and I solve for x. So I get 2x equals 4 right off the get-go. Now to solve for x, I'm just going to divide both sides by 2 and I end up with x equals 2. Now this is a point in and of itself. It has an x value of 2 and a y value of 0. So to plot it, I'm going to go right 2 and I'm not going to go up or down. To find the y-intercept, you're going to let x equal to 0. So when you have your equation 2x minus y equals 4, you're going to let the x value be 0, which is going to make the x term go away. 2 times 0 is 0. So I'm left with minus y equals 4. So again, right off the bat, I just cross out the x value and whatever's attached to it when I'm solving for y. So that I would end up with, divide both sides by -1 or multiply both sides by -1, I get y equals -4. And again, this is a point in and to itself. It has an x value of 0 and a y value of -4. So I have a point down here, 0, -4. Now, technically, is that enough points to graph a line? Debatable. In the next lesson, we'll learn one more feature that we can use to graph lines. If you didn't feel confident with this being a straight line, find a third point. Plug in x as 1 or 2, or 3 or 4 or whatever it is you want to plug in, and then check to see if it makes a line. But I'm going to trust it. And again, you always extend your line beyond the graph. I'm going to connect those 2 points like that. And another thing you should add is arrows on the end. I didn't do that on the last graph. It shows that this goes on and on forever. So some teachers insist on the arrows, some don't care. My rule of thumb is as long as the line reaches the end of the grid, I assume it to go on forever, but just to be sure, put arrows on. I know there's an instructor, I think at Selkirk, that actually takes off half a mark if you don't put your arrows on the end. So just get in the habit of it now. So if I wanted to check if this was a line was right, I could pick another point. You know, I could pick a point that my line went through, like 3, 2, and I could make sure that it makes the equation true. So something like 2 times 3 minus 2, does that equal 4? 6 minus 2 is 4. Yep, I'm good, right? So all I really needed was those 2 points to graph a line, but more points are better. All right, let's move on to this next one. So again, I want you to find the x and the y intercepts of this equation. So you can pause the video and give this a go. I'm going to find the x-intercept by letting y equal to 0. I get 3x minus 0 equals 0. which leaves me with 3x equals 0. Divide both sides by 3. I get x equals 0. So my x-intercept is a point 0, 0. I'm going to plot that right now. The next thing I'm going to find is the y-intercept, which I'm going to let x equal to 0. And I get 3 times 0 minus y equals 0. I get negative y equals 0. Divide both sides by negative 1. I get y equals 0. What happened? Well, my x-intercept was 0, 0, and my y-intercept was 0, 0. How come? Because as soon as you get 0, 0, that's through the origin, and that's the x and a y-intercept. So how can I graph my line? I only have one point. Well, that's why we don't only learn this method for graphing lines, because people are like, finding x and y-intercepts is the best. You cross out x, you solve for y. You cross out y, you solve for x, and I've got my graph. And it's like, well, yeah, but not always. So in this one, I need another point. So let's plug in, I don't know, x is 1. So I get 3 times 1 minus y equals 0. Now, I would just add y to both sides, but most people would subtract 3. So I get negative y equals negative 3. Divide both sides by negative 1. I end up with y equals 3. So there's another point. 1, 3. Now, technically, is that enough to graph a line? Yep. But if you wanted more, plug in another value for x, plug in another value for y, whatever you want to do, and then just connect the dots. Now, I'm just going to give myself a little guideline. I know it's coming, so there we go. Okay, so connect the dots. Put your arrows on the end. And that is my graph of my line using the x and y intercept, and an additional point because the x and the y intercept were the origin. All right, good luck.